Almost everyone is here. So let's wait a little bit. It's also not really quite time to start yet. Um, while we wait, you guys can see what we'll do today. It's kind of continuation of our previous activity. Um, okay, and now we have someone else. We're still waiting for Tina. Tony, did you see there's the new Pokemon game trailer?
Oh yeah, I know. So one is talk about the Asian, and another one is talk about the future. Maybe I think.
Yeah. Do you know what one you will get?
Maybe I will get a future one.
I think that is also what I will get. Um,
I saw one about, I don't know if that's made by Pokemon or something else, but it's like kind of like Pokemon, but the trainer, like they can like have guns, like like fight with the Pokemons. I think there's you can like check it, but I think there is one.
You have to send me the name of it so I can check it, but it does sound like something I would like.
Altos?
What is
No,
it?
no. I don't know. It's like made by like the office.
And energy conservation to look at planet temperatures. But today we're also going to include the greenhouse effect. So yesterday you calculated planet temperature without greenhouse effect.
Wait, just see.
Mm-hmm.
So if a planet there's no atmosphere of the planet, so are there any greenhouse effect?
If there is no atmosphere, there is no greenhouse effect. But
so why the moon also have the albedo? The surface.
Yeah, so that's because it's not a perfect black body. So you're right. Yes, the surface. It's a rock, so it has the albedo of a rock. But yeah, good question, Tony. Thanks. Um, let's take a look at what you did yesterday. So I gave you this exam problem to follow and do some online research to look up the relevant data. Um, but the exam problem, it gives you the formula for planet temperature. It says you should be able to derive this formula from the information that is given. So before we go and do some more problems, let's derive this formula. So here's the formula. And to derive it, you should have an energy balance to start with. So this would be something like, so I want to ask one of you if you can annotate the screen, like draw on it like this, to show us how to get this final formula.
I can.
Okay, you want to do it? Go for it. Okay, I think it looks great. It looks just like this one. Can you explain this step here, Tony?
What? Oh, okay. So just change S into P divided by 4 pi d squared.
Yeah, so just plug in. And then why did you write this is equal to this?
Because the energy in equal the energy out, so they have the same intensity.
Yeah, great. Thanks so much. But yeah, so this equation looks really scary. So many terms, but it's not so complicated. It's really just a simple idea. Copied our results from yesterday here. I did delete Mercury's temperature and Moon's temperature because I think you didn't quite get the right calculation at the end, so I want you to try again today and see what temperature you get. But at the end of class, we're going to talk about the differences and explain them between the observed and predicted temperatures. And actually, that's one of the questions your group should answer in the new version of the shared document. one of the things that will help you explain this, so think about this as you're giving your explanation, is the greenhouse effect. So Ethan, hello Ethan, are you there this morning? Are you awake?
Yes, I am.
Hi Ethan. Can you tell us, what do greenhouse gases do? You can read from here.
Greenhouse gases strongly absorb IR and radiate some of it back to Earth.
Yes, thank you, Ethan. So we can include this in our planet energy balance equation. Let's see how we do that.
Excuse me, what is IR, like in this case?
Oh, infrared.
Okay.
Yeah. Infrared. Good question, Abe. Yeah. And the wavelengths of infrared are around 10 to the minus 5 meters. If you can keep that number in your head, it's sometimes helpful, but not important. I'll leave that up there, though. So we're going to include it in the energy balance now. And remember, energy in, energy out. So let's look at the Earth and the atmosphere. What is the energy coming in according to this figure? Lily, can you tell me? Oh, you're quiet though. Can you maybe fix the microphone? Can you tell me what energy is coming into the Earth, being absorbed in this photo?
Rich energy.
Energy coming in.
Solar energy.
Huh?
The solar energy.
Okay. So this one, you mean?
Yeah, and I see it is the solar intensity minus the energy reflected.
Oh yeah, so good. Actually, you pointed out this part here. Oops, that's not. Yeah, so this part is the solar energy coming in, but minus the reflected. Good. Do you see any other energy that comes into the Earth? Look at the arrows pointing down.
It is the greenhouse energy.
Yeah. Same groups as yesterday, so you are working with the same planet. And you each have an individual question to answer. Let me share the link to you guys again. It's the same link as yesterday. And I have the correct numbers. You can check your calculation with me before the end of class. Copy the link. Send it to WeChat. And then I'll put you into the breakout room.
好，那我写一下，我写一下大概公式。好。我觉得应该拿 iPad 过来做。这是 greenhouse。打出来是这个，能看见吗？
可以看见，
也可以。
应该没啥问题。对，这个东西等于啥来着 ？Teacher?
Yeah? Oh. Yep, I'm here.
What is this? What's the constant of this?
Oh, it is 5.67.
OK.
不小，有点小，没看到。
我刚刚看错了。
那我写清楚。
我们就按照这个公式把它算一下。
然后乘以735的4次方，
对，
减去1减0.689乘以 p 是多少？昨天那个
p 是那个3.9乘以10的26次方。
Q 题按计算器，快点。然后4派 d 是多少？
d 我看。
Wow. Jesse, I post my message, but I still don't know why it is different
Okay, is there a way you can show me the work?
in the chat box.
Okay. Alright, so this it's weird because it does look like it's correct to me, huh? But yeah, change the 10 to 11.
So it's 268.
Yeah, maybe. Yeah, that's what I got too. Okay, now your answer matches with mine. Okay, so we found that error. Now you will calculate how much atmosphere intensity the moon needs.
But the moon doesn't have the atmosphere.
I know, this is going to tell you like how much atmosphere would the moon need. Like how much gas will we need to bring to the moon if we want to live there.
Okay. Yeah, I think we have a logic for that.
Okay, good. I'll come back in a little bit to see if you have any problems. And so far, 2 groups have filled this out. So for the moon, maybe Abe, do you want to tell us what, explain the moon's temperatures? Do they agree or do they not, and why?
Yeah, I think we made an agreement on this because I think it's quite close, and plus, like we don't have to consider a lot about the greenhouse gas effect since like the moon does not have an atmosphere, so therefore we should like get the close like calculation to the actual result.
Yeah, I think that is a good answer. So the moon doesn't have an atmosphere, you say that? Yeah, so there's nothing being reflected back. What about from the Venus group? Maybe Bonnie, do you want to tell us whether your temperatures agree and why you think that is?
I don't agree because there is a big difference between the calculation and the actual temperature.
Yeah, so why do you think that there is such a big difference?
I don't know why.
Well, what did your group write in this column? Can you read this?
Atmosphere
Re-radiate.
Radiate back to the surface.
Yes. And you calculated how much. It's over here, right? Now, Mercury hasn't put a reason in here, but I'm going to ask maybe Alex. Based on what the moon people said and what Venus people said, do you think that Mercury's temperatures agree? And then do you think that means that it has an atmosphere or no atmosphere?
So it might have.
Why do you say that?
It's like compare with the difference between Mars, between Moon. It's similar, like not a big difference.
Okay, so you think it's similar to the moon?
Yes.
All right, so based on being similar to the moon, do you think it has atmosphere or no atmosphere?
So maybe I need to check. Moon have atmosphere?
what does the moon group say in their box here?
Oh. Oh, so it's more close to moon and there's no atmosphere.
Yeah. So yeah, if the
Yeah.
temperatures agree, maybe no atmosphere. This one, I think, should seem very familiar to the activity that I had you do last period. Let me give you maybe 5 minutes to do this and then send your answers to me. I'll check.
So for this question B, like surface temperature, we should consider the what's called the reflection or not.
So, Abe, what does this sentence right here say? What does this mean to you?
I forgot if like the black body will have any reflection rate or not. Yeah, that's my blind spot.
Okay. So
okay, yeah, okay. Now
yeah.
that makes sense. Yeah, sure. Now that makes a lot of sense.
Okay, good.
Just I send it to you. The first one is the answer of A, and the second one is B.
Yeah, I think that it looks pretty good. Okay, what about some other students? I want to check in because some of you have calculated it, and some of you haven't given me an answer yet. So like Alex, where are you at? Have you? Can you calculate this? And you're not sending it to me, or do you need?
So the typing is a little bit slow.
Okay.
I'm still typing.
Okay. Tina, what about you? Do you need some help, or do you think you can send me your answer?
Yes, I'm saying okay.
Okay. Ian, what about you? Okay, Lily, I think you are also correct. Good. Okay, good. Alex, thanks for showing us the calculation. I like that. Abe, yes. Ian, yes. Lily, yes. David, yeah, that's okay if you're not so sure. It looks like you guys are getting to the right answer. Yeah, Tina, good, good. For those of you who maybe didn't, let's take a look at how you actually get this. So I'll ask Lily, do you think you can tell us how to calculate A?
It is because the distance of Mars equal to 1.5 distance of Earth. So I just let the S to over 2.25, which is 1.5 square.
Okay, so S over 1.5 squared. You guys also got that one correct. Abe, do you want to tell us how you got B?
Hello?
Yeah.
Hello? Is it work? Okay. So basically, yeah, the idea is quite simple. We just put the two formulas together. So first, the I formula of 1 minus A times S divided by 4. So considering that A is basically 0, so we don't have to consider like 1 minus A at all because it will just be 1. And then we just plug in the S and divide it by 4. So that will give us the actual intensity on the on the surface.
Mm-hmm. And this?
Yeah, and then like we just put that together with the other formula of E, and that I don't know how to say that symbol, like the one with value of 5.67 times 10 to the negative 8 power.
Yeah,
like,
it's sigma.
Just times this, and then this sigma, and then just times temperature to the 4th power. So yeah, and then just basically work backwards to get the temperature.
Yeah, it was like 226 or 225 Kelvin. One of those, depending on whether you use, I think, this one. So let's think. If you need help with C, I'm going to give you 2 sub-questions to think about. first, it says that the greenhouse effect is not significant, but is carbon dioxide a greenhouse gas?
It is.
Yes, thanks, David. Yes. So that would make you think there should be a greenhouse effect. The planet should be warmer. That's why Earth is warm. So look at the second piece of information that's given. What do you think it means that the pressure is less than 1%? What if atmospheric pressure is very low? What does it tell you about the atmosphere?
So it's very thin.
Yeah, very thin. So very little gas. So even though there,
Oh, so the albedo is very small.
I think that will also be true. Little atmosphere, little albedo, but also very little gas or radiation reflected back down to the surface. Especially names I haven't seen come up in a while, like Caleb. I haven't heard from you today. Ocean, Sean, Ethan, Jairo. Want to hear from you guys for this question. So the diagram shows a simple model of energy balance in the Earth-atmosphere system. The intensities of the radiation are shown here. Okay, so what is the average intensity radiated by the atmosphere towards the surface? Okay, Sean is really fast.
Excuse me, what is the surface absorption like exactly? Like, what does it exactly mean?
So if the arrows will kind of help us understand what the term means. We see that this line is kind of like a straight line, meaning it's from the same
Yeah,
source.
right.
Mm.
Oh, okay, so they're actually the same thing. Is that right?
Yeah,
So
but
it's like the same incoming. Okay. Okay, I see. I get the idea.
okay, good. All right, and then we have, okay, Sean and Lily and Tony and Alex say B. Jairo says B. Tina, what do you think? Also B. Okay, yeah, you guys are right. Okay, so I'll give you guys a couple minutes to fill in the things you need to review. It seems like one person's not interested in after school review, but they also got 100% on this quiz, so you're fine. Also, you guys have done really great on the quiz in the end. I really suggest you use the ESQ, the exam style questions in your textbook. It gives you a little bit of a taste of everything, unless some of you have question bank and you can use that as practice. But if you don't have that, use the Unit 7 and Unit 8 ESQ as a practice to test yourself. You guys,
Oh, wow.
Yeah, you guys can go. But if you have any other questions, please let me know. I have time. We can talk about it. If not, go have lunch. Have a good day. See you. Bye.
So see you
Bye.
next week.
See you next week. Bye.
See you, Jesse.
See you, Ian.